So those are those two definitions, but what we're going to do is we're actually going to put them into action today. Okay? You guys are really used to seeing minimums and maximums in what kind of functions? In quadratics, right? Parabolas. You guys understand minimums and maximums, right? Really well. And we kind of saw that proof last week on like how we found the vertex, or not last week, but last chapter. So what we have to be concerned about is, it says on the interval, okay? What that means is I might have a restriction within my domain, okay? Which means I'm going to make sure my x's start and end at a certain value, okay? So here's example 1. Here's what I'm talking about. So for example 1, let's say f of x is equal to x squared plus 1 on the interval -1 to 2. Okay. So again, this is what I'm talking about. This is my domain for this function. That means I'm not allowed to have anything that's less than -1, and I'm not allowed to have anything that's greater than 2. Okay. So what do we know about this function before we even start? It's quadratic, which means it's going to make what kind of shape on a graph? Okay, so let's just even graph it on that interval from -1 to 2, right? Let's just kind of get a feel for what are we actually looking at. Okay. So as I go and graph, if I plug in the value of -1, what do I get? What's my y value if I plug in -1? I get 2. So here it is. There's a circle. I'm allowed to fill in that circle because it says, oh, what am I doing? Sorry. I know. Sorry. My fault. Okay. So -1, +2. Again, I'm allowed to fill this in. Okay, because it says I can include that value. And then let's just go to 2, and let's see what happens when I plug it in. So when I plug in 2, what value do we get? 5. So let's see if I can count that correctly. 1, 2, 3, 4, 5. Okay. And again, I'm allowed to include it, so I'm going to fill it in. Okay. And just kind of knowing some things about parabolas, I understand that its minimum is going to happen when x is 0. So if I plug in 0, my value that I'm going to get is 1, okay? And again, because they mirror each other on either side of the vertex, I know that that point's also going to be at 1, 2. So here I go, there's my graph. That's what I'm looking at, okay? So guys, if I was to ask for what is the minimum here, what is the absolute minimum, what is the lowest point on this graph, what would you tell me?
0, 1.
It says 0, 1. Okay. However, the maximum, where is the maximum for this?
5.
So it's at 2, 5. Notice in this case it happens to be at one of my endpoints, right? Okay, I didn't realize I moved it, sorry. So, if I wanted to prove why the minimum was happening here, what would you do? How could I prove that this is a minimum? You could take a derivative and prove that the slope is what here? What kind of slope would this produce? It produced a slope of 0, right? So if I took the derivative of that, f prime of x is equal to 2x. I know my slope there is 0. So what does my value of x have to be?
0.
Which is what we just proved right back up here. Okay? So, one way instead of graphing this and actually figuring out on a graph where the max and mins are, we can do this with calculus using derivatives. Okay? So, here's what we're going to do. To find maxes and mins, are you guys okay with that abbreviation? Okay. So to find maxes and mins, you set the derivative equal to what? To 0 And what else do we also have to test? What else did we have to test? Because we had a maximum occur where? It occurred at 2, 5, which was on my what? So, okay. So to find maxes and mins, you find the derivative, set it equal to 0, solve for x, right? We're going to plug those x values in. And then we also have to check our endpoints. Okay, because in this case, if I set the derivative equal to 0, was it going to show me that either one of these was a maximum? No, okay? I had to actually physically go back in and check why are those a maximum, because it's where my domain is ending. Okay? All right. So we're not going to graph this one. We're just going to do it with calculus. Okay? So here's example 2, and I'll move it down in a second. So example 2, I have the function f of x equals x cubed minus 3x squared on the interval, notice, -1 to 4. This time, I'm not including the endpoints. How do we know that? Okay, because it's open brackets, right? So I'm not including them. So, in this case, I do not need to worry about plugging these in, because I'm not including them. So, if we're going to find a maximum and a minimum, we have to take a what first? Derivative. So we're all pretty good at this. This is power rule. So f prime of x is, in this case, 3x squared. Now, ladies and gentlemen, I looked at our tests. Our factoring was not there like I wanted it to be, which made me a little sad. But that's okay. So what are we going to do with this derivative here? Well, first of all, set it equal to what? 0. Set it equal to 0, okay? So 0 equals 3x squared minus 6x. And then we looked at this and we were all like, oh, how do we do this? Well, factor it, right? What can I take out of both 3x squared and negative 6x? So I can take out an x and I can take out a 3. So 3x, you're going to get x minus 2. So what does this mean?
2 points were...
Okay, so I have 2 possible points, right? I have one of them where 3x could equal 0, and I also have x minus 2 could equal 0. This means that whatever values of x this is, I could have 2 horizontal tangents occurring. Okay, so what is this value of x here?
0.
So x is 0 in this case. What is this value of x here?
0.
Okay. So again, I'm not quite done. These are where horizontal tangents are occurring, but do I know if they are maximums or minimums yet? No. How are we going to figure that out? Plug it into what? Exactly. We're going to plug it into the original equation and see what those y values produce. Okay? So, f of 0 in this case is going to be 0 minus 0, which is 0. Okay, so f of 0 equals 0. And then f of 2, I'm going to get 8, not 6, minus 12. It's going to be negative 4. So in case you never realized why function notation is nice, it's because it tells me the ordered pair. This is 0, 0. This is 2, negative 4. Which one is which? How come the minimum is 2, negative 4? Because the y value, right? The y value is smaller than 0. So this happens to be the minimum. Okay? And this one happens to be the maximum. Do you guys have questions? So, in this case, we do not need to check the endpoints. Not because we have both, but because these are not included.
Oh,
Okay? Because these are not included, we do not have to check them. It's not the absolute maximum or minimum. These are what are called relative maxes or mins. Okay? Or local. Okay? All right. Example 3. Guys, am I going too fast, or are you guys okay? Okay. So f of x equals 2x to the 5/3 minus x to the 2/3 plus 3 on the interval -8, comma, 1. Okay. So looking at this, what kind of rule are we going to use? We're just going to use the power rule. Okay, we're just going to drop that power. So again, first step we need to do is find the derivative. So f prime of x is equal to 2 times 5/3 x to the 2/3 power minus 2/3 x to the -1/3. And if I take a derivative of 3, that's just 0. Okay. What do I do from here? I'm supposed to take this derivative and set it equal to what? 0. Okay. So 0 equals, I'm just going to make this 10 over 3, okay? Just a 10 over 3, x to the 2/3. And then I'm also going to minus 2 and make that -1/3 go in my denominator. So 3 x to the 1/3, that's all in my denominator. Do we have any questions on that? I can zoom in a little bit for you too. Okay. So how should we go about and solve this? I'm not in this case. I would not. I know. I could factor it, but the first thing that I'm going to do is I'm going to move this over to the other side. Okay? Yeah, I'm gonna move this -2 over 3 x to the 1/3 to the other side, okay? So I'm gonna add it to both sides. Why? You'll see. Does anybody see something really, really nice?
Cross multiplication.
I could cross multiply, right? What's 2 times 3? 6. What's 3 times 10? 30. X to the 1/3 times x to the 2/3 is x to the 3/3, which happens to be 1. You guys with me? Huh? Did I do anything illegal? No.
I've never seen it done before.
Cross multiply?
No, I see. In this fashion.
Oh, okay. So now what do I need to do to get x by itself? Divide by 30, right? So, if I divide by 30, 1 over 5 equals x. Now guys, don't get me wrong, I've had a lot of experience with these, so I can see some of the patterns. You guys will get there throughout the year, okay? So, x is equal to 1/5, right? So, can we talk about, what does this point mean? What does that mean right there? This is where a what is occurring? A min or a possible min or max, but a horizontal tangent maybe. Okay? Does that make sense? A horizontal tangent is probably occurring here. So, what are the points that we have to test?
-8 and 1.
We have to test -8. We have to test 1/5. Thank you. And she's not here. And we have to test 1. Do you guys see that? We have to test these 3 points. Does that make sense? Okay. So, I'm going to plug in f of -8. Let's do that first. Can you guys see it on my screen? So 2 times -8 to the 5/3 minus 2/3. No, whoa, yeah, don't do that. Sorry, minus -8 to the 2/3 plus 3. Sorry. Okay. So, a lot of us look at this and you're all like, where do I begin? Well, what's -8 to the 1/3? -2. So I have 2 times 2 to the 5th. You guys with me? Negative 8 to the 1/3 is negative 2. So now I'm just going to put that to the 5th power, which means I'm going to be subtracting negative 2 to the 2nd plus 3. Okay? Negative 2 to the 5th happens to be negative 32 times 2 is going to be negative 64. This is going to end up being just minus 4 plus 3. This is just math. I'm going to get negative 65. So f of negative 8 is that value. Okay? This is not calculus. This is just algebra. Okay? Guys, I'm going to save us a little bit of time. F to the 1/5. If you put it in your calculator, you have to go to 3 decimal places, is 2.795. Okay? And what's the last point I had to check? 1. F of 1. 1's really nice to plug in because I have 2 times 1 to the 5/3 minus 1 to the 5/3 plus 3. These. So I get 2 minus 1 plus 3, which is equal to, which is 4. Okay. So let's look at this. Based upon my y values, where is my minimum occurring? Negative 8, negative 65. That's the point. So here's the minimum. Where's my maximum occurring? At 1/4. So do you see how this point right here, that 1/5, 2.795, it's not the maximum or the minimum. So it's not that it's not important, it's just that on that interval, it's not the highest or the lowest point. Okay? Are we good? All right. Let's do example 4. Now we have 2 more examples. So, example 4. Let's have f of x equal x plus 27 over 2x squared on the interval included 1 to 5. Okay. First things first is you should probably take a what? Derivative, but I don't really like the way this one looks, so what could you do to it?
X to the negative 2.
Yeah, we could change that exponent so it's negative, right? So maybe just make that function a little bit nicer to work with. 27 over 2x to the negative 2nd, and now take a derivative. So f prime of x in this case is equal to 1 plus 27 over 2 times negative 2x to the negative 3rd. You can go through, clean that up a little bit, and then set it equal to what? A 0. So guys, I'm allowed to use that same trick that I just did. I can make this negative 27 over x to the 3rd, move it to the other side. So I have 27 x cubed equals 1. I can multiply by x cubed on both sides. So I get that 27 equals x cubed, which means x has to be what in this case? What 2? They cancel. 2 and negative 2? I'm sorry. Sorry. 2 and negative 2? Yeah, that's why it's a minus now. Sorry, my bad. So then x is equal to 3. Okay. And guys, as we're going through this, just give yourself about 15 seconds, try and follow the math. Okay. And understand what points do I have to plug in. Do I have to plug in the 1? Yes. Do I have to plug in the 5? Yes. And what's the other one that I found that I also have to plug in? The 3. Okay. So I usually like to do them in order. So I'll do like f of 1, f of 3, f of 5. Okay? So f of 1 will just, f of 1 will just be equal to 1 plus 27 over 1 squared. 2 times 1 squared, yep. So 1 plus 27 over 2. If I want to think about it in terms of a fraction, it's just going to be 29 over 2. That's what f of 1 is. Okay. F of 3 is going to be 3 plus 27 over 2 times 3 squared. 3 squared is 9. I'm going to simplify this at the same time. 27 divided by 9 is 3. So realize I'm simplifying this fraction right here to 3 halves. You guys okay? You could do it the long way. This would give you 18. 27 over 18 is 3 halves as well. But then again, I'm going to get that common fraction. So 3 times 2 is 6. 6 plus 3 is 9. So I get 9 over 2. Okay. And then 5. I'm going to get 5 plus 27 over 2 times 5 squared. So I'm going to get 27 over 50. I got it as one big fraction. That'd be 250 plus 27, so 277 over 50. Okay. So guys, which one of these is the minimum? So this one's really close to like 5.5. This one's really close to well, this is 4.5, and this one is about 14.5. Okay? So which one of these is the smallest value? F of 3. Okay? So this one is the minimum right here.
You wrote F of 1.
No, I didn't. I just changed it.
You're all doubting yourself. She's like,
Sorry, that's my fault. Yeah, you're right. It should be definitely F of 3. Okay, so that's the minimum because that's where it's occurring. Where's my maximum? At 1. So your max is occurring at 1 and 29 over 2. At this point, it's nice to know, but it's not a max or a min. Okay?
how would our question be phrased to find the, would it be like, we just look for the maximum minimum on this?
Yeah, find the relative maximums or minimums. Okay? They're called extrema. Find the relative extrema. Okay, and last one. Last one. All right. Last one for today is going to be g of x equals, I know, g of x equals secant of x. Yeah. I told you.
Why is it semicolon? Is that J or a semicolon?
Is that semicolon? So why is a semicolon necessary? What am I trying to tell you here? The domain, okay, on that interval. So, guys, where do we start? Find the derivative, or we could have this memorized, which I don't, but I will tell you that it is secant x, tangent x. If you could change, well, I do, but not really. I do just because it's right in front of me, but honestly, if I didn't remember, what could I do to help me? You could use quotient rule by changing secant x into 1 over cosine. Okay? And for those of us that are still having a hard time, who goes with who? Cos, no goes. Like, cosine does not go with cosecant. It's cosine with secant, cosecant with sine. Okay, cos, no goes. They just don't go together.
I remember that one, and then it messed me up with cotangent because cosine is first.
But cotangent and tangent, like...
Come on.
So, okay, so g prime of x in this case is equal to secant x, tangent x. Okay, and again, we have that written down. You could go back and find it. I'm not worried about you guys getting to that calculus part. But this is why trig quizzes are so important. Okay, so what am I supposed to do from here? Set it to 0. So 0 equals secant x and tangent x. And for those of us that are like, what do we do from here? These are factors. Secant x is being multiplied by tangent x. So I'm going to take each of these and set them equal to 0. Hang on. So guys, let's remember what is secant of x. We just said it before. It's 1 over cosine. So wait. I have 1 over something that's supposed to equal 0. This is not even possible. So in this case, this is not possible. So here, I'm just even going to put not possible. You will not find an x value there. Okay?
Cosine x is near 0 on that interval.
Okay. Well, let's not worry about that yet. And then over here, 0 equals tangent of x. To help me out, let's even remember what tangent is. Okay? Tangent is sine over cosine. Now guys, we just got done saying we don't want this to be 0 in the denominator. What's the only thing we're worried about here? When sine of x is equal to 0, right? So the question is, when is 0 equal to sine x?
Pi over 2 and 3 pi over 2.
So sine is related to the y value, guys.
Oh, sine is pi over 2.
So,
Oh my gosh, that's really good.
okay. So guys, if we go back, sine is related to the y. The only time that occurs is here and here. What values are those?
Oh, 0 and
0 and pi and 2 pi, right? Now, hang on. Guys, we don't want all of these. We only want the ones that are in our domain. What's the only one I'm allowed to even try and plug in? 0. So I don't even want these. They're not in the domain. Because my domain is from negative pi over 6 to pi over 3. Okay? So I can't even plug in pi or 2 pi. So now, the first one that I'm going to plug in is g of negative pi over 6 is equal to, well, let's see, secant of negative pi over 6. Again, it helps if you change secant equal to what? Okay, so 1 over cosine. This looks awfully familiar. Cosine of negative pi over 6 is going to be right here, right? So this is going to be radical 3 over 2, comma negative 1/2. Which one of those do I want? Radical 3 over 2. So 1 over rad 3 over 2, or if we simplified this, g of negative pi over 6 is, 2 rad 3 over 3. Okay. Ooh, you can't see it, sorry. It would not, because we're talking about the x value here, not the y value. Okay, the next value I'm going to plug in is going to be 0. So g of 0, I really like this one. 1 over cosine of 0 is, no, cosine is equal to 1 comma 0, guys. 1 over 1. So g of 0 is equal to 1. There you go. And then lastly, g of pi over 3, 1 over cosine pi over 3. So if you go back up, pi over 3 is 1/2. Radical 3 over 2, the one that I want, is 1/2. So I have 1 over 1/2, and that simplifies to 2. So guys, the question is, which one is the largest?
2.
Yep. So how do we decide that this one doesn't work for us?
It's a fraction. It has a radical.
It's not necessarily true, but if I got a common denominator between all of them. So 2 radical 3, right, over 3. If I made g of 0 3 over 3, and I made g of pi over 3 equal to 6 over 3, that can help me measure a little bit easier. Do you see what I'm saying? So like here, the question is 3 less than this? It is. Okay? Is 6 greater than this? Yes, it is. So here, this is my minimum. Your minimum is occurring at 0, 1, and your maximum is occurring at pi over 3, 2. And again, guys, I just took this step to help me understand how to measure that. Okay? You don't have to. Okay. Are we good?
Wait, why isn't it radical plus 2?
Because that is still greater than 1. This is still greater than 1. It's like 1.155. Okay?